Hello, welcome. Today we'll have a look at day 4 Ceres search for Advent of Code 2024. So for this first part, they want us to locate every Xmas, and it can be diagonally, backwards, up, down, left, right. So in this particular example here, I think there's a total of 18 times. So that's pretty much the entire problem. Let's go over how I did it. So initially what did I do here? So I started here. I opened the data. Let's use test here. Test 4.txt. And then I came up with this here. So let's print it out just so we can get a look at it. So G star G separator equals, and we'll print rows and column. Put that up here. And just for us to get a look at that, and it's fine. Okay, let's run it. Okay, so Python, what is it? Problem 4. So we see that there's 10 rows and 10 columns, and so what I've done here is I have opened the file and I loop through each line. I strip off the new line at the end of it. Let's see, what is it? Test 4. So as you can see, there's a new line at the end. So I strip it off as in the previous problems, and I convert this to a list of strings, and then I append it to the graph, or I just call it G. I could probably call it matrix. And then I loop through. I start here. So I go through every row and every column, and what I look for is I look for an M. I look for an X. Everywhere I see an X, I perform the search. I search up, left. I search in all 4 directions. And so during the crunch time while I was trying to solve this as fast as I could, I didn't want to come up, or I couldn't at least, I didn't want to spend time to think about how to consolidate this into one function. But let's just go over 1 or 2 of these to see how I did it. So search right and left. So let's go up to them. So remember, we're allowed to go in any direction, up, down, left, right, diagonal up, diagonal left, diagonal right, etc. So let's look at search right. So I made this recursive. So I pass in the row and column, and I make sure, and I notice here's P. So I call this P as in for pattern or Xmas. And notice how I always start at 0. I start at 0 here, so that I want to check, even though I don't need to, but I probably could have made it more efficient if I put this at 1. Maybe I can do that. Yeah, maybe I can do that later. Maybe I can do it now. In any case, so I just started at 0, and since we're going to the right, I know I'm going to be adding 1. So for here, I just check if this is perfectly fine, and then I go to the next. This is a recursive call, so I go to C+1, because remember, we're going to the right. I want to check something like this. If we're in a diagonal or on a column, I'm looking for this. So that's why I keep adding 1 to the column. I don't know what that's about. And then I just carry on. I keep doing this. And I check if either I'm out of bounds or that isn't the right letter we're looking for. So that's why I keep incrementing I. So I plus 1. So I'm checking for the next letter in P. And remember, I set P to Xmas. And if it fails somewhere, it returns false. And same thing kind of for left. For left, same row, but I only need to ensure that the column is greater than or equal to 0. I check if the index is correct for that position. And if it is, I continue on. Once I reach 4, I just return true. And so it's a recursive function. And this is basically the same thing for all of the functions. And if you notice, I just add them up and I return the result. Later on, of course, after the contest, I did kind of think about how I would do it. So I said, well, let me just make a generic search function. So now, undoubtedly, I still need to pass in the row and column. But now it needs to know which direction it's going. So I decided to pass that in. And I still need the index. So then I still need this terminating, I guess, case or terminating requirement. Once we get beyond the end of Xmas, then we can return true. That means that's good. So notice here how I am only checking if R is less than rho. I would need to be more comprehensive in my check. So what I mean by that is I don't know exactly what's happening as far as dr or dc, delta R, delta column. I can be moving up, down, left, right, diagonally, so I need to be more comprehensive in my check. So I would need to add this entire more constrictive bounds for rho. It would need to be above or equal to 0 and less than rho. And same thing for the column. And that would be the first change. What else? This is still the same. Now here, I need to pass on whatever delta R is, and same thing here. I need to pass on whatever the delta column is. And that was all that was really needed for this. It's kind of a shame I didn't think of it during the contest, but it's fine. You know, I'll work on it. Oh, I also need to change this. Okay. And in that case, I need to somehow formulate how to search through all the different delta R's, delta rhos. So I did come up with, what is this? Yeah. So here's this here. And remember, this is -1. So the -1 means it's up one row, to the left one column. So up one row, same column, up one row to the right, etc. So then we would do something like for dr, comma dc endures. Then we do something like count plus equals search row column dr dc, and maybe I wonder. Let me think. Yeah, I think it's just easy if I just do it like this. I think 0 is fine. Yeah, I wonder if I would need to change this. Let me think. If this is 1, so we know I is 0, that's good to go. Then this is 1. This might work too. Yeah, that might work. Let's try that. Yeah, let's run it. Let's clear this out. And then we still should get 18. Okay, maybe we didn't. Let me take this off. Put the 0, I think. All right, what's wrong here? Oh, I know. I'm sorry. I forgot to pass it in. So this search here, I forgot to pass in what dr and dc are. No problem. Let's clear that out. Okay, 18. And let me just check this again. I want to make sure that this failed for some reason. I'll look into it later. I don't know why that. I think that should work. Yeah, I don't know why. I think I need to adjust this. Yeah, I'm not sure how. If I just change this to that's not right though. I think if I do this here. No. Yeah, I'm not sure. I'll think about it more. But for now, this is fine. It's 0. And so we get. I shouldn't be printing this graph. It's fine. Let's remove that. It's annoying me. In fact, both these are annoying me. So it works. We get this, and that's the value that was in the example. So 18 times. And so that was it for the first problem. The only bad thing is I didn't come up with a. I had to write uh, an explicit an explicit function for each direction, and that might have been a little dirty. And I'll work on trying to come up with something more clever during the contest as opposed to after. Um, part two. So let's go over part two. Part two says now they're instead of looking for xmas, they're looking for this. See where this x is? It's like a wordplay. So they mean more like a diagonal. So diagonals of mus. So or mas. So they're looking for mas. Now one thing that messed me up during the contest was I didn't read that they're okay for this being backwards or forwards. I didn't see that earlier. So I was looking for simply this exact configuration, and that didn't yield the correct answer. So what I mean by that is instead of seeing, like, for example, here they have this Sam. For them that's okay, because it's forwards or backwards. So I overlooked that, and I didn't account that earlier during the contest, or not the contest, but while I was solving the problem earlier. So in any case, let's see how I did it. So in this one, same thing. Every line has a new line at the end. I strip it and I just add it to this graph. And then I do almost the same exact thing as in the previous problem. I run through all of the rows and all of the columns. Then I ask myself, do I see an M? If I see an M, I'm going to check for MS or MM. So let me tell you what I mean by that. Let's see if I can do this here. So if I see an M, I'm looking for this. I'm looking for M space S. That's what I mean by MS. And then this is still an A, and then here would be an M, and this would be an S. So that's what I mean when I have this function here, check MS. For this check MM, I would be looking for something like M.M. This is still an A, and now in this case this would be S and S. And similar things for SM. I'll just go through one of them really quick. So SM means I'm looking for S dot M, A again, and in this case I need an S here and an M here, and something similar for SS. I'll just run through one of these really quickly. So for MS, it's just a bunch of if-else statements. For MS, so I know I've seen an M. Now I'm looking for the S. So on the same row, I want to advance 2 spaces on the column and check for an S. Add 1 row and add 1 column. So notice I didn't add a check for the C+1. That's because I know it's good enough because C+2 is okay. So I don't need a check for R+1. Sorry, C+1. So, but I am checking for an A. Now I need to go down 2 more rows to check for the last 2 letters, and I don't need to check for C+2 here because I've already conducted that check on the first one. So that was it. I just do something similar for all of them. It was quite straightforward. And then, well, let's just check it. Let's just check it. What did I do? Where is it at? So for this one, they wanted to find 9. So let's just check that really quickly. Find 9. Here, I think. Python problem 4 part 2. So we get 9, and that's pretty much it. One thing that was kind of I wanted to ensure was that to make it easier to prevent duplicates, I only look down and to the right. So if, for example, if I see this M here for for basically all of them, I'm only looking to the right and down, so that won't conflict with any duplicates. So I think this problem was easy in that respect because we didn't need to worry about duplicates, meaning I wouldn't double count anything. If I'm always counting down and to the right, I'm perfectly fine. I don't have to worry about double counting. And from this part, remember, I'm always looking forward here. See how there's always pluses? So that made the problem somewhat straightforward and easy. I'm always looking forward and down. And again, that made that easy. That was just something I was worried about, but it wasn't an issue. Okay. If you have any questions or comments, let me know and I'll try to answer them. I am somewhat concerned because I think day 5, the level of complexity rises more so than what they have been. But we'll find out. Fingers crossed. Other than that, have a great day. Take care.